geometry students, Mr. Zacek back and better than ever here. We're in Unit 6, so cranking along through the units, and we're going to look at today the Polygon Angle Sum theorems. So before we get to that specific theorem, and I'm excited because I got a song for it, hip hip hooray, and but we'll talk about some definitions. So a polygon is a closed figure whose sides are line segments. And we have two types of polygons. We have convex and we have concave. Convex, you can see with this diagram, that's kind of the typical one that we will look at. So our most common ones are going to be convex. And concave, the way I remember concave is, I think of it like if you were to punch in one of the corners, it would cave in. So it caves in the corners. That's how I remember the difference between convex and concave. Now we've got some the different names for them. The triangle, we're familiar with that. Quadrilateral, that's a four-sided polygon. The pentagon, the hexagon is a six-sided. Hepta or septagon, a seven-side, either one of those would work for that. Then we have the octagon, which is an eight-sided, a nonagon, which is a nine-sided, a decagon. I'm just going to add one more. A dodecagon is a 12-sided figure. Beyond that, we'll just use the number of sides. Okay. Now, when we think about polygons, we have to define what a diagonal is. And a diagonal is a line that connects any vertex to a non-adjacent vertex. So if we draw all the diagonals we can from one vertex, that's the only diagonal we can draw in this quadrilateral. In the pentagon, however, we can draw a diagonal here, and we can draw a diagonal here. And in the hexagon, if we started here, we could draw a diagonal to this vertex, we could draw a diagonal to that vertex, and we could draw a diagonal to this vertex. And so the question is, what conjecture can we make about the relationship between the number of sides of the polygon and the number of triangles formed? So let's just kind of answer that question for each of these. Sides, triangles. Okay, sides, triangles, sides, triangles. Okay, well in this first one we have four sides, and how many triangles are formed? One, two triangles. Here we have 1, 2, 3, 4, 5 sides, and we have 1, 2, 3 triangles. Here we have 1, 2, 3, 4, 5, 6 sides. We have 1, 2, 3, 4. So we have 4 triangles. And so the sum of the interior angle measures of a polygon depends on the number of sides the polygon has. So it depends on the number of sides. So the sum of the interior angle measures, what they all add up to, by dividing a polygon with n sides into n minus 2 triangles, we can show that the sum of the interior angle measure of a polygon is a multiple of 180. So notice here that 4 triangles, there's always 2 less triangles than the number of sides. So n represents the number of sides. We subtract 2, that gives us the number of triangles. All right, and then this gives us our formula, the Polygon Angle Sum formula. The sum of the measures of the interior angles of an n-sided polygon is S equals 180 times n minus 2. So here's how I remember it. N minus 2 times 180 is the sum of the interior. N minus 2 times 180 is the sum of the interior angles. N minus 2 times 180 is the sum of the interior angles of a polygon. All right, the song goes on, but we're going to stop there because that's all we've got so far. Now, an equilateral polygon is a polygon with all sides congruent. All right, notice the tick marks. An equiangular polygon is a polygon with all angles congruent. Notice the angle tick marks. A regular polygon is both equilateral and equiangular. So this is a key vocab term. Regular means that it's equilateral and equiangular. So if you want to find one angle, then you divide the sum by the number of sides. So n is the number of sides. So for example, let's take one that we know. Let's say we have an equilateral triangle. Okay, has 3 sides. So 3 minus n minus 2 times 180. So the sum of the interior angles is 180. Now we already know that, but it just, the formula supports it. Now if we want to find one angle of this regular polygon, we do 180 divided by 3, the number of sides, and we get 60. All right, 60, 60, 60. So the way the song goes, if you want to find one angle, divide the sum by the number of sides. If you want to find one angle, divide the sum by the number of sides. Anyway, one angle, divide the sum by the number of sides. One angle inside a regular polygon. All right, we could keep on going, but we've got other content to cover. So the polygon exterior angle sum theorem says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So I just want to talk about that for just a little bit, just to demonstrate it, because it seems a little vague. And we did earlier in the year, we looked at so we'll do a triangle, and let's do a square. Let's do a pentagon here. All right, and let's do maybe just I don't know, maybe let's put a dodecagon on. Okay, so how do we find exterior angles? Well, exterior angles are found by extending one side. So the exterior angle is always adjacent to the interior angle, and you find it by extending a side. Well, what happens is, as you go around here, you start to realize that the more sides you get on this, the more it starts to look like a circle. All right, I'm not going to keep on doing that, but I think you get the point. So the sum of the exterior angles of a polygon is always 360. It doesn't matter how many sides, it's always 360. All right, so what is the sum of the interior angles, the measure of a heptagon? Well, a heptagon has 7 sides. So here's our formula. The sum equals n minus 2 times 180. It's the sum of the interior. So 7 minus 2 times 180. So 5 times 180, which is, I believe, 900. Okay, so the sum of the heptagon is 900. What is the sum of the interior angles of a 17agon? Okay, well obviously that's a 17-sided figure. So we're just going to apply the same formula, right? That the sum is n minus 2 times 180 is the sum of the interior. So the sum is going to be 17 minus 2 times 180. Okay, 17 minus 2 is 15. 15 times 180 is 2,700 degrees. Obviously, it's increasing. Now, we flip this question around. The sum of the interior angle measure of a polygon is 1,980. How many sides does it have? So here's our formula. The sum is n minus 2 times 180. So we know the sum is 1980. We need to figure this out. Now, some people would go and they might distribute the 180 first. I think it's a little bit easier if we understand that you can divide by 180. It'll make just the overall calculation a little bit easier. So 1980 divided by 180 is 11. And then we would add 2. And so there would be 13 sides on that figure. All right. Question 2. The common housefly, Musca domestica, kill those stupid things, has eyes that consist of approximately 4,000 facets. Wow. Each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? Okay, key word here, regular. Regular means equilateral. So the first thing that we need to do is we need to find the sum for a hexagon. Sum is n minus 2 times 180. So the sum is 6 minus 2 times 180, which is 720. Now, if you want to find one angle, so one interior angle, we're going to take the sum and divide it by the number of sides. So we take 720 and we divide it by 6, okay, and 720 divided by 6 is 120. So an interior angle is 120 degrees. So what is the measure of each interior angle of a regular nonagon? All right, so I'm going to kind of put this whole thing together. Interior angle, again, this is regular, so they're all the same. So it's n minus 2 times 180. That's the sum. If you want to find one angle, divide the sum by the number of sides. If you want to find one angle, divide the sum by the number of sides. Wanna find one angle, divide the sum by the number of sides in a regular polygon. Okay, so we get 1260 divided by 9, which is 140. What you're going to notice is, as the number of sides goes up, the interior angles increase. So in the last one, it was 120 degrees. Here it's 140 degrees, okay? And that will continue to go up. All right, so some other types of application questions that we have with this. What is the measure of angle Y in pentagon today? Okay, so in order to figure out what Y is, we need to know the sum of the pentagon. So the sum is going to be 5 minus 2 times 180. So 5 minus 2 is 3. 3 times 180 is 540. Now, we know the angles here, so measure of angle Y is the one we're trying to find. We've got 110 plus 120 plus 150 plus 90, and all of that together has to equal 540. So if we do 110 plus 120 plus 150 plus 90, we come up with 470. So the measure of angle Y plus 470 equals 540. So we would subtract 470 from that, and we would find that Y is 70 degrees. Okay. What is the measure of angle G in the quadrilateral? Now maybe in a quadrilateral, you already know that a quadrilateral, we have a little more familiarity with it. Maybe we don't need to do the n minus 2 times 180. Maybe we already know that that's 360. So we're going to do plus 120 plus 85 plus 53 equals 360 degrees. So that's just kind of a prior knowledge piece. And so we do 120 plus 85 plus 53. So the measure of angle G plus 258 equals 360. So we're going to subtract 258 from 360, and we will get 102 degrees. Okay. Now, in question 4, now it says find the measure of each exterior angle of the triangle and show the sum is 360. All right, so here's one of the relationships is that an interior angle plus an exterior angle always equals 180. Those are supplementary. So if we look at our diagram here, we find that the 30-degree angle is the interior. That means 150 would be the exterior. Up here it would be 80 because those two form a linear pair. And here it would be 130. They form a linear pair. So show that the sum is 360. So 150 plus 130 plus 80. All right, those are our three angles. And we get 360 degrees. All right, now in B it says measure of angle 1 in a regular octagon. Okay, again, regular is means they're all the same. Octagon is 8 sides. Here's the difference. This is an exterior angle. While the exterior angle, it still is the sum divided by n. The difference, however, is that the sum of an exterior angle, all the exterior angles, is 360. So I'm going to do 360 divided by 8 to find this angle here. So if we take 360 and we divide it by 8, we get 45. So the measure of angle 1 would be 45. Okay, what is the measure of an exterior angle of a regular nonagon? Okay, so this is a little bit less work if we understand it correctly. Regular, okay, but it's exterior. The sum is 360 divided by 9. So an exterior angle of a regular nonagon is 360 divided by 9, which is 40, I believe. 40 degrees. Okay. So I think that is the, let me just check here. Are we at the end of our lesson? I believe so. Things are clicking forward. Yes, we're going to go on to the next lesson. So a lot of little vocabulary. Nothing is too hard in of itself. The key for us here going forward is going to be able to make sure that we recognize the specifics and pay attention to the details and get them into our thinking. All right, good luck, and I will see you soon.